Hello, you golfing legends, and welcome back to another episode of the original Off Course. I'm your host, Dan Edwards, and joining me once again this week, and now laughing at my great intro, is the legend himself, Master Mike Yagley of Cobra Golf fame, among other things. So, my friend, welcome back.
It's good to be back. Thank you, Daniel. And thank you for that introduction. Yeah.
Do you not like my intro? People dig it.
I love it. What would you say? When you say hi, what was it? Hi, all you golfing legends.
All you golfing legends. Yeah, they dig awesome. That. Yeah,
that's so awesome.
I was actually playing golf last week with an old friend, and we hadn't played in a while. And I think he's 74 this year, and is just in my books the legend. Like, he still moves the ball off the tee just fine. We got 2 beers at the turn, and he put those down just fine. Like, to me, he's the epitome of a legend. And you know, we all play this game in our own way and have fun and score in our own way. And I look at it like, hey man, if you can't go out there and feel like a legend and hit a legendary shot once in a while, then what are we doing?
Yeah, I totally agree. And the beauty of the game too is, like, he's 74 years old. You just keep playing. Well, I've got buddies who are like, oh, gee, I can't play baseball anymore. I can't play tackle football anymore. Yeah, but I sure can play golf. Yeah. It's awesome.
I think I read a quote somewhere out there that said, on any given day, a 15 handicap can hit a tour level shot. And it's unlike any other sport in that, because you can't just go yard for 400 feet with the baseball bat, or, you know, that's such an interesting point. And it might be accidental. No one said it was intentional to hit the tour level shot. Like, they might have been trying to hit it high and hit a low screamer that's fun. But I think that the great normalizer, then you have the ability to find common ground there as well. You go out and golf is your shared passion, and then you can find ways to engage and interact and learn. To me, is the beauty of the game.
It really is. And then if you're, I wouldn't say paying attention, but if you know what's going on with a lot of these athletes, like the baseball players, the extreme sport guys, and now a lot of the basketball players, what do they do in their off time? They play golf. They play golf. Yeah, they love it. You know, at that level of competition in their minds and with their buddies, right? For them to be able to experience that level of satisfaction, sport's hard. We all know that. It's really hard. It's really challenging, and I think that's why they get after it.
So it makes me think of another conversation I had this weekend with my regular playing partner, who's quite good. Like, you'd be impressed with the way he strikes a ball, Yags, but we talk about, you hit 3 perfect shots and your 4th is just an absolute turd. And it's like, oh yeah, golf's really freaking hard, isn't it?
Yeah. Well, and it goes both ways too. It's like, so you're playing a par 5, you hit 3 perfect shots and you make a double somehow, or you hit 3 really crappy shots and somehow you skank out a birdie. It's like,
right.
The game at times makes no sense.
Here's another no-sensor. I hit 3 great shots on a par 5 and left my eagle putt like on the edge of the cup. So that massive drive I hit is the same value on a scorecard as that little doink I did at the end to get it in the hole. I love that too.
Oh yeah. Hate might be too strong a word, but I think that's why Hogan said he hated putting, for that exact reason, right? A 1-inch shot is the same value of a perfectly struck, in his case, 1 iron from 230 yards out. Right. Same value.
Well, I'll tell you what, man, it's awesome to have you back on the show so quickly. I think our last show was fascinating, and people really enjoyed how freely we spoke about product and some of the design intentions that you guys have going over there with Dark Speed. What no one knew is you had this iron you were sitting on, like, I think the following week, that originally had us set back our call because you thought I wanted to talk about that. It's called Cobra Limited, and it is one of the more ridiculous ideas I've seen lately. A huge separation from what we typically would expect out of an iron, and this really, to me, falls under that 1 + 1 = 4 conversation, and I'm excited to have you on to sort of celebrate it a little bit and give people some reasonable discussion to hear and chew on a little bit. So I want to set the stage with, how in the hell did you go from, oh look, a 3D printer, to printing sets of irons that are wildly forgiving as compared to what they look like?
So I use this phrase all the time, to the point where just before I say it, my boss will say, "Oh yeah, Yagley's about to say that's not trivial." Okay. Um, and your legendary listeners may have heard or read some of the stuff, right? It's like, hey, if we had done this 10 years ago when we started dreaming about it, actually started dreaming about it probably 16 years ago, before I was even with Cobra. That's where some of the patents started, because they saw that the possibilities around 3D printing, and they could see the future. Um, I'm going to go off the rails just for a second. It's kind of like when um, Walt Disney's widow was standing with some executive or some media person, and they said, "Man, it's a shame that Walt can't see." This is after he passed away, of course. Walt can't see what this all became. And she said, "Oh, he saw it. Don't you worry." Okay. And it's the same thing with this. I mean, 16 years ago, the guy saw that at some point we're going to be able to print metal, and we're going to be able to make golf clubs from it, golf club heads. Um, Fast forward a little bit, let's say to 2012. Okay. I remember sitting in a room with a bunch of the guys, and we were discussing what's possible with 3D printing. And we had a couple vendors come in, and we could see it like, oh boy, we're going to be able to print metal and do some really funky things with it, but they're going to cost like literally $500 per head. Like, wow. You scratch your own head. You're like, well, that's not going to work. I mean, it would for prototyping, maybe make a couple for tour, but you're not going to make a set of irons for someone. You might maybe make a driver and you charge them $5,000 for a driver once you get the whole thing finished, or $20,000 for a set of irons, but it's not there yet. But again, we saw the possibilities. We knew that at that time, literally at that time, you bought a flat screen TV and it might have been $10,000 to hang it up on your wall. And it was a good TV. Well, now that same thing costs $750 or $1,000, and it's even better. It's lighter, has more bells and whistles, and you can buy it at Costco for a tenth of the price. And we didn't know how low the cost of 3D printing was going to go, but we knew it was going to go down. And one of my guys, Ryan Roach, has scoured the earth for different types of 3D printers, different types of 3D printing, noun, verb, right? Different materials. And it's all come together a lot faster than we thought it would. I mean, we're able to make these limited irons in a cost-effective way so that we can sell them. They're not cheap, right? They're $3,000. But that dream came to fruition a lot faster than we thought. So a lot of it was the technology, it was the material, it was the cost, and my guys worked their butts off to make this happen. So I'm really proud of what they've done in a lot shorter time span than we thought it was going to happen. A lot shorter.
So yeah. the original introduction to 3D printing, I guess you will, like we've seen it with the putters now, and it's a very fascinating thing. When it was early on in the company, was it the idea was, hey, there is some utility to this early on, or was it like we are going to go into this in a very forward-thinking, solve for the future type of thing? And I want to circle that back to, you mentioned creating prototypes or whatever it may be. That there's a difficulty that goes into that in this day and age when you want to create, let's say, a driver or let's say a putter and see the results of the way you've structured it. It's not the easiest process, right? You have to get a mold, you have to introduce a lot of those things. Was that a part of the early conversation, is that this might make prototyping a little bit easier?
Yes, for sure. You mentioned the word utility, and that's a great way to phrase it. The utility for us was we could make, let's just start with an iron. We could make an iron, could have been a wedge, fairway, hybrid, putter. So I went off the rails quickly. All things made of stainless steel. And we could make a prototype that was hittable from when the CAD file, which is a computer-aided design file. So let's say you got to make it, whether you're going to cast it, forge it, or 3D print it. That file's done. There is the design from an engineering standpoint, not necessarily with the industrial design on it, but it is the head. and we want to prototype it. We could get a head from 3D printing within a couple of weeks, where if we had to tool it up, as you described, be it forge it or cast it, it's going to be months. It could be 3 months before you see the parts. So the difference between weeks and months is massive for us. In the time you get one iteration through traditional casting or forging, we could potentially get, wow, 1, 2, 3, we get 5 or 6 iterations. And that's if you do it serially. If you did it in parallel, where if you're printing a whole bunch of variations at the same time, you could get 10 variations in a couple of weeks if you did them in parallel. And we've done both. We've done where we're going to try a couple different versions, or let's get one and iterate on that, and then iterate on that. And it's great. I mean, the technology is just flipping amazing, because the as printed parts now have the same integrity and clearly the same feel, same structural characteristics as whether you've forged it or cast it, which is massive.
Yeah.
Think about
we definitely need to get into that, but I don't want to go too far ahead of ourselves, because I still think there's a little bit of conversation here. And what I'd love to hear is there are so many different ways to go about it, and this is something I'm sort of celebrating in the industry right now, is there's a lot of different ways to resolve a quality product from start to finish. And in your case at Cobra, is this 3D concept becoming sort of the champion of the conversation? I know you use other programs and other ways to refine the design, but is this starting to become more of the identity of Cobra, or is it just simply an additive product of their final result?
That is such a great question. And the answer, I'm afraid, is probably going to be TBD, because we just released this to the world. Now, granted, we did a putter back in 2020, but that ended up looking like kind of a one-off. We did that Super Sport 35, which was phenomenal. Sold out, 700 of them sold out in like 36 hours. And we couldn't take that particular type of 3D printing and turn it into the iron that we see now. It's just a different process. It just can't do what we had to use to make that iron. But that was like the first bright star shot over the bow. And we've done a whole bunch of prototyping. I mean, a lot of prototyping for tour. We've had probably, I think when added up 2 weeks ago, it was 43 different projects that we've done for tour, and about 14 or 15 of them actually got put in the bag. And they weren't all intended to be put in the bag. There was stuff to test, studies to be done. Since then, that list has got to be up to almost 50, and there's one more that's in the bag. Just in 2 weeks since we first put that presentation together. And it's been fairways. There's been a couple hybrids, sets of irons for a guy who got a lot of love for playing a 3D printed set of iron back in the Masters. But we did that for him years ago. We didn't really talk about it much for all sorts of reasons. And then we've done wedges, where we've scanned Ricky or Gary or Jason Duffner's favorite soul grind and catted that up, reproduced it in 3D printing. The players take literally one swing through the turf, and they're like, yep, that's it. Where poor Ben Showman was doing it by hand, and he may not get it right the second time or the third time, and he's got to keep doing it until Ricky goes, yeah, that's the right grind. But now we can duplicate it. So there's all these things that we're able to do with 3D printing.
I want to stop you there.
Yep.
I want to stop you there because you made an interesting point of saying that you did it years ago, but you didn't talk about it. And I'd love to know, is it because the idea is so foreign to golf that there is such a process in place? Or is the idea like, hey, this is kind of our thing right now, and we're really getting ahead of this part of the process. Let's not show our cards just yet. Let's refine it to the point where we really bring out something hot and then share it to the world what we're doing here.
I think it was a little of that, and the second one, or the first one, I should say. And then also, hey, there's also the stigma of, yeah, but I can't play what the pros are playing, right? Like they're playing something different. And yeah, it was true. Um, Mr. DeChambeau was playing a 3D printed set of irons because we didn't want to tool up a whole new King Tour set for just him and make like 4 sets for his playing time. It's like, no, it's way, way smarter, way like more efficient, just better to 3D print them. And he couldn't tell the difference in them. They felt the same. So there's a little bit of all that. And it was so new. It was like, are we really going to be able to make commercial products from this process? And then there's also the, hey, how interesting is the process? Now, in this particular case, I think 3D printing is extremely interesting because you can do things you can't do with casting and forging. But look at with the King Tour, and when we metal injection molded it, we mimed it, which sounds flippin' really cool. I mean, metal injection molding, ooh, that's awesome. That process didn't resonate with people. It just didn't.
I don't know that direct metal laser sintering will either.
I know. Well, the thing with MIM, and when you cut it open, you look at it and you sniff at it, it looks the same as you forged it. Okay, so do I really care how you made it if it looks exactly the same? In this particular case, this is a very different beast. I mean, when people see the inside of it, it's like, what? It's not hollow, but there's a lattice on the inside, and a lot. I was going to say boatload, but my marketing people love it when I say boatload, so I just started saying, okay, a lot. There's 100 grams of tungsten that's been relocated, mass that's been relocated in the form of 100 grams of tungsten, and you nerds out there know these irons weigh what, 275 to 375 grams, whatever the range is across a set, like 300 grams. I'm sorry, 100 grams. I got too excited. 100 grams you've moved, when you've heard nerds like me get all excited about 3 grams, hell, sometimes 1 gram. Ooh, look, we found a gram. It's 100 grams. Holy crap. That's a lot of mass. So to be able to do that, 3D printing is just way more interesting than metal injection molding for that purpose alone.
Well, yeah, let's play into it a little bit, because what I've done is I've pulled the iron up on the screen for everyone to see who's watching via video. Those who are obviously listening via audio will have to try and walk around the conversation as well. But on the surface, really, if you're not paying attention, it looks like a traditional iron with a little bit of visual technology that exists there. And frankly, we've seen comparisons to other irons or even a set of wedges that had a milled backing to it. So to the naked eye, to the unfamiliar onlooker, it could just be that you decide to take tiny little blips of weight out of the back of the iron to create more of that cavity profile. But really, it's what's on the inside of this iron that should showcase the real components of what makes it special, right?
Correct. Yeah. That you hit on that grid on the back is, I was going to say, mostly industrial design, mostly ID, so that you get an idea that this is not like your daddy's blade. Does it help move some of the weight? Yeah, a little bit, but the real magic is on the inside. There is actually a wall between what you see on the back of the iron and the lattice on the inside, because we did not want water, soil, grass, sand, anything to be able to get inside that cavity. So that's why we had to put a wall up there. But inside that is a very special lattice that has been highly engineered to allow us to, and it's funny, when I talk about it now, I have to realize with this process, we have to accommodate the manufacturability, the mass properties, the feel properties, and then of course, when I say mass, it's also being able to move that mass, all that simultaneously. It was not, as I've said before, it was not trivial to say, okay, we're just going to put a lattice on the inside. And a lot of our patents or intellectual property is going to be around, okay, actually making this thing, how you manufacture it, not just what it is. And that's pretty unique with this.
So
that's,
when we see this here, this component here, with the wall it's internally, if that lattice visual wasn't there, would it be somewhat of a very subtle cavity back iron? Is that sort of the shaping without it?
Without that honeycomb grid that you do see?
Yeah, you had mentioned there was an internal wall, so it does just allow you to rotate the weight a hair more to improve the overall results?
I would say more than a hair.
Okay.
And I would share some stuff. I don't think, because you're on the website right now, right?
Yeah, I'm just kind of scrolling through a little bit on the website to showcase some of the components of it.
Show the actual internal, and I will. We'll stretch. We'll fill right now, okay?
Yeah, absolutely.
Yeah. So as I pop this open, I want to find one image which really shows. I'm going to put this up here. Shows what's going on the inside. And I want to present. I'm going to share a screen. Going to let me pick a screen? Come on, baby.
We'll get it right, folks. Just give him a second. He's going to show us some really interesting stuff. I assume your plan here, Yags, is to showcase the internal structure.
You see it now?
Oh, yeah. We'll get it up there right here. There we go.
All right. So for all you people that are just listening, I'm so very sorry that took a good 45 seconds to pull an image up. For the ones that are watching, you're like, oh, that's interesting. So that's the lattice on the inside. And I love the geometry, by the way, that we used. For all you golf ball nerds, dodecahedron. Remember the old Maxfly DDH? If you're old enough to remember that. Classic dimple pattern. Well, the lattice that we used on the inside is that same geometric configuration. Now, of course, it's a lattice structure. It's not like a geometry on the exterior of a golf ball, but the lattice is a dodecahedron. And as you're looking at that image, and I'll describe for people that are listening, it's not like it's perfectly oriented, vertical, horizontal. It's not orthogonal to either the ground plane or the face. I mean, it's at some interesting angle. And that was born from the manufacturing process. That structure, as you're building it, and you're building it layer by layer, 2,600 layers of DMLS, as you described before, direct metal laser sintering, right? 2,600 layers of laser comes through and basically sinters or melts all of the powder at that level. And then you put down another layer of powder and you do the same process and another layer. And so you're building this thing. And as you're building it, it needs to be able to support itself, which is a unique part of the whole 3D printing process, especially if it's an internal structure. External structure, you could actually build in support. You could build a scaffolding, as you might look at it, that you would remove after the part's been printed. And if anyone's seen polymer parts, now metal parts, a lot of them do have this structure around the outside. And you just snap it off and you either sand it, polish it, whatever, and you've got a pretty little part. We can't do that on the inside. So that's what I was talking before about the intricacies of optimizing the structural properties, the mass properties. I don't think I'm through in the structural before. So it's structural being like durability and sound. Okay. So structural, mass properties, manufacturable, I can say it. That's what we had to consider when we're building this thing. And I encourage people that are listening in their car or, on the golf course right now, whatever they're doing, like find this image. It's all over the internet now.
Yeah, you can actually find it. Dean wrote a great article on our homepage. You can find it there. It's basically, and I'm going to dumb this down to everyday golfer terms. It's basically two fat pieces of tungsten at the bottom of the head with large open cavities that they go in there to showcase some of the weight that they've redistributed. And then basically where you'd expect there to be mass inside the head, or stuff, if you will, it looks like a bunch of empty blocks, empty squares that are connected. So Yags, just for fun, I'm gonna ask you the same question I did when I first saw it, which was, talk to me about durability. It's such an interesting design, and I'm sure you tested it like crazy. But there will always end up being that question: is just exactly how durable can an iron like this be?
That is, again, such a great question, Daniel. You're so good at this. You should do this for a living. So we had massive concerns because, as you described it, and people that can see it and people that find it, the little legs of the lattice are really pretty tiny. They're not big. And we're like, are these things just going to snap off? I mean, when somebody hits a 4-iron 50 times, are these things just going to break and you're going to have all sorts of little chunks of metal run around the inside? That was a very legit concern. Well, we got that one guy I mentioned, BAD, and then we also have Kyle Berkshire, who was just going through utility irons left and right, the stock ones, because those have a thin face. They're intended to give someone a lot of pop, right? Well, that guy's swinging 135 miles an hour. They might have lasted 50 or 100 hits, and that's just not going to work. So we're like, okay, we're going to build one very similar to what you see on the screen right now, but it's a utility iron. And that lattice structure goes from the back of the face all the way to the front of the back. And that's really critical. It is attached all the way, and as heel and toe, right? So that lattice structure is attached to everything on the inside. And of course, itself, as that lattice structure goes through the head. So for us, was an amazing crucible, as I might say. Very, very severe testing environment. And they survived.
Wow.
And we held our breath. We're like, okay, not only did they survive, they last a long time, even for him. And that was the first like bellwether moment. We're like, okay, this is going to work. And then, of course, as we're starting to make full sets of irons with this technology, we're testing the crap out of them. We air cannon every single head. Like usually we would test like a 4-iron and a 7-iron in the set. It's like, okay, the rest of them will be fine. Oh no, we tested them all. Like we made some 3-irons, but like the primary sets, 4-iron through pitching wedge, tested them all in the air cannon at tour speeds, thousands of hits. It's like, these things can't break. There's no way. That cannot happen. So
it is funny when you add when you add the additional variable of these little components here, you quickly overlook the fact that we are going tighter and tighter and thinner on these faces. And listen, if you've ever been on the internet, Yags, people cave them in. It's not an uncommon thing, especially dependent on the manufacturer. So the idea that this would be overly concerning, but you're willing to accept the zero support of a thin-faced metal wood, for example, it is something that I really resonated with when I started thinking through it. Like the structural design here. And another example I like to use is when you look at bridges, you see how functional they are with the limited amount of metal that are used. Yes. And sure, when something fails, things change fairly quickly, but you know, the durability that exists because of the way that it's structured it should not be ignored.
No. And for all you super nerds out there, there's a lot of things that look like they're very almost like delicate looking. Like you mentioned bridges, like suspension bridges. Well, a lot of what you see on a suspension bridge is in tension. You're pulling on it. And when you're pulling on something, it can be a hell of a lot stronger than something that when you're pushing on it. When I say stronger, they have similar mechanical properties in both directions, but if it's really thin, when you push on it, it will collapse. Okay, like a cable. You pull on a cable, you can put, tons and tons and tons of weight on a cable when you're pulling on it. But when you're pushing on it, the cable just collapses. We have both going on here. You look at that lattice structure, there's going to be segments that'll be in massive tension and some that'll be in massive compression. So again, I'll use the phrase for the third time, not trivial to make this thing work. This is an engineering feat.
Yeah.
And there's so many. I'll go down one path right now.
Yeah, dude, please.
If you're going to let me go.
Yep.
the 3D printing world has been clamoring for this. Not the golf world, but the 3D printing world, because there really hasn't been, and actually they might call themselves additive manufacturing, okay? Because this really is additive. Most manufacturing processes are like subtractive, because you're taking a chunk of something and you're removing things, classically. In this case, you're starting from a powder, which is literally about as fine as like powdered sugar. That's how fine this stuff is. One of the reasons it's expensive to make these things, because that's, again, difficult to take a chunk of metal and turning it into a very, very fine, very consistent powder. So anyway, the additive manufacturing world hasn't seen a lot of consumer products that have been made from additive manufacturing, either DMLS or binder jet or all these different ways to make chunks of metal. There's knee joints and hip joints and rocket nozzles and F1 car parts and really obscure car parts, or some sort of part where the original tooling is just gone. You can't find any parts, so somebody's making a few parts for you. But I'm gonna say there hasn't been any, and that's a big word. Don't quote me on that one from a trademark or an intellectual property standpoint. But we can't think of any true consumer products that were 3D printed out of metal, that weren't just cute with something you put on your desk or a shift knob in a car, like functional, a functional, honest to goodness metal additive manufacturing product. And because of that, we're going to get a ton of accolades from the additive manufacturing space. Like Ryan Roach, our director of innovation, is going to be presenting at Rapid it's a conference for all these additive manufacturing nerds. They are so excited to get him. He's going to be a keynote speaker, a flipping
Wow.
keynote speaker. That's how big a deal this is. I mean, you can imagine at technical conferences what some of the titles of those things are, right? The atomic weight of stainless steel 316, blah, 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 and its functional use in DMLS. Like, that's the title of some of these things. This is like, no, we made some golf clubs. Cobra Golf made some golf clubs.
Wow.
They're going to be ecstatic to have like an honest to goodness, like, you made something, you get to sell it. It's not just theoretical. Yeah.
Okay, so I have the one big question that would be on my mind, as someone who prefers to play a smaller package iron but desires the benefits of the larger style. I mean, we've always said play as forgiving as you can stand to look at, right? That's always been my perspective.
Agreed.
But you've done more here, but at what cost? And what I mean by that is the primary discussion that a lot of people have when you have that finite profile is the quality of the sound is uncontested in some of the larger style heads.
Yes.
And when you're presenting this type and shape, I would hope that sound and feedback is a primary point of conversation when you're designing it. So the question ends up being, there is a fairly consistent style of manufacturing that goes into, let's say, a muscle back or a player cavity. How much is that lost, or how much is that change going to this DMLS using the 316L, which is the metal?
Well, literally all of the feedback we've gotten, all of it, from tour players to intercept testing, did a little bit of that, any of the internal testing, had a few people from outside the company that were in the building were like, hey, could you hit this? And then, of course, all of our internal testing, which I wouldn't take with a grain of salt, but it's our internal players. But all of them, 100% of them, have all said, yep, feels like a blade. Yep, that feels good.
Wow.
And and we held our breath on that one, because that was like a non-starter, right? It had to like legitimately look like a blade. And when I say a blade, is it a Ricky Fowler super thin top line RF33? No, we didn't want that. Tiny bit bigger than a muscleback, smaller than our King Tour. And our King Tour is played by Ricky Fowler, Justin Suh, and a host of others. Okay, so that's blade-like enough. If we took that thing and shrunk the blade length a tiny bit, made it a little bit shorter from a height standpoint, and then gave it a little less offset, thin the top line a little, I mean, no one argued with that. It's like, yeah, the King Tour looks great. This thing looks even better. So now you've got, feels like a blade, looks bladish enough, okay? And then all the stuff we talked about from a performance standpoint and moving 100 grams of weight, I mean, that's the trifecta. You started in the very beginning of the conversation, like, thinking about different types of irons. And as we did it, we're like, okay, we want to make an iron that is remarkable in its performance, and it is remarkable to a group of people that can like detect it quickly, and furthermore will appreciate it a lot. Imagine giving someone, and this is what we've done, someone who, I just described this thing, a little smaller than a King Tour, a little, maybe a tiny bit bigger than an MB. So it's in the blade category, feels like a blade, but it's forgiving like a dark speed iron, maybe more than a dark speed iron, honestly. It's paradoxical to these players. They hit it, they're like, what is this thing? I've had amazing moments in golf. I mean, amazing moments. And outside of golf, from an aerospace standpoint, like, worked on projects where I got to slay a dragon. Not I, the team got to slay a dragon. Little bitty contractor wipes out Raytheon and takes a massive contract from them. Did some really cool things at Boeing. You know what I've done? No, what I was part of. Had a Rule 35 golf ball at another company that was a Pro V1 before there was a Pro V1, right? We worked our asses off to make that. I mean, that was a lot of fun. That was tour players going, geez, you made a golf ball that is as long as a two-piece distance ball but spins like a balata ball. What is this thing? I mean, they were confused. I'm telling you right now, we're getting the same sort of reaction. Players hit it and they're like, what is this thing? This makes no sense. I see what it is and I can tell how it feels, but it's behaving way different than my brain expectation is.
Right.
I hit it on the toe and I expect to lose 20 yards because I should lose 20 yards. Damn it, I missed it, and I don't. What is this thing? This is at the top of my career moments right here.
That's incredible. And we get to celebrate it with you.
Yeah.
So I asked that question because you and I have had very long conversations in the past individually, or I suppose just sitting in an office or sitting on a golf course if we're lucky enough, and talking about your willingness to commit to sound and feel being what they are directly linked. And it all stemmed back from my original excitement. Do you remember when I jumped into that, was it the Speedback 4-iron?
Yes.
And just lost my mind. It was the same year that Ricky did it at the Waste Management. I said, if he can do it, I'll do it. And the quality of the sound off that just blew my mind because it wasn't such a separation from what I would traditionally play. And you reminded me every time we talk, like it does matter to us. It is an important component that everyone gets to enjoy the quality of the sound that when they hit a good ball. And the idea that it can continue into this and not be subtracted from the quality that the products you're putting out is really exciting to me. But I want to ask one additional question about the manufacturing process, because you did mention 316L, which is the metal you use. How much freedom do you have to work with other materials? Are there other options, and will we see continued refinement of that?
Oh yeah, absolutely. I mean, for you and all the other nerds out there, you've heard 17.4, 431, 316, 305, right? We can work with all those. All right.
Okay.
I would say I'd have to look at the list very carefully, but I'm pretty sure like most of the stainless steels, titaniums, that you have heard being used to make golf clubs, we can 3D print those now.
Nice.
Yeah.
Okay.
It's really exciting. Yeah.
Sorry, go ahead.
No, I was just going to say, because there's people like, why? Why would you use different types? Well, that you have to accommodate 1, manufacturability, 2, durability, 3, bendability, and then the thing we just spent a lot of time on, like, ultimately, how does it feel? Okay, so you get looking at all those simultaneously. There's a plethora of materials available right now in the quiver that we can pick and choose. This one just rose to the top. It just did. For all those reasons, yeah, you haven't heard much of 316L. It just worked best for this iron.
Okay. So
Yeah.
I want to ask something that's been brought up, and I guess it kind of runs twofold. And the question would be that, are these very much a concept release? Are they're obviously limited? Is it based on the ability to manufacture? And then the price associated with it, is this something like, will 3D printed irons be of this ilk when they do come out? Or is this just like, hey, we have the ability to create 500 of these, we want people to hit them, and this is what we can do at this time?
I've said this like 7 times now. It's a great question. Okay. That's a great question. I would say, I hate saying TBD, because there's so many things that are available at this point. We could make more of this same thing, right? Because we can. We could make improvements to it. And improvements would be in the eye of the beholder, right? This iron is spectacular for what it is. Could we make it better at the exact same shape? Sure. But then, as I lean in, what's better? What is better? Is it more moment of inertia? Is it move the CG around, right? Don't need to change the feel. So let's just leave that, okay? What's better? That's the beauty of all this, Daniel. It's like, I mean, the canvas, as you might say, is really broad, like really broad with this. Jose Miraflor, who we all know and love, he's like, man, let's make a game improvement iron out of this. Like, we could, right? We could make a better blade out of it, like a true blade. You're left up to, almost to your imagination. And so I'm not even being coy. It's like, we have all sorts of options. Here's what I would tell you. There will be more. Okay. Yeah, there will be more.
From a units available standpoint, are you limited to the what you can print and the time that it takes, or how does that work? Because I've seen, and I'll set the stage for that a little bit more. We've seen conversations in the past where processes are done using a different form than traditional methods, and it forces you to be limited because you only have enough resources with what you have. So is there an opportunity to expand on that, or is it, this is kind of where it is for now until things change significantly?
Both phrases are right. Right. This is what we have for now. So like the supply chain that we have, and the number of machines that are available to us right now, and we found a couple great partners to work with. I'm not going to say any more than that. Right. Like, they're phenomenal. It sounds simple, but hell, buy more machines, right? So let's say you've got 4 and they buy 4 more. So you just doubled your capacity. So for right now, the capacity constraint would be printing them. Just printing them. Like, how many can you print in a week or a month, or however you want to quantify it, depending upon how the supply chain guys look at it. That would be the constraint. But like I said, the beauty of that is buy more machines. It's not, when I say that, it's not like the machines are just sitting there and you buy 2 and you can plug them in and they're printing tomorrow. But you can buy more machines. And the other beauty of it is, this isn't like casting and forging. And you've seen the videos. I don't know if you've been to a casting house or a forging house. There's a lot going on. You're in casting, you are melting metal in a furnace, and there's guys in asbestos suits pulling that molten metal out and pouring it into molds. Or, sometimes it can be automated too, right? It's a huge commitment from a building size standpoint, and the equipment and the energy going in and the labor. We're talking about a machine that's smaller than the size of my office that you plug in. It's not this trivial, right? But it might be one guy running it. That's it. So the possibilities around this are just amazing, from a performance standpoint, from a manufacturing standpoint, from a supply chain standpoint. It just is. That's why I'm so giddy about it.
Yeah.
You
I
might,
really need to work on my camera effort, because what
yeah,
you guys aren't seeing on audio right now is when he gets excited, he gets really up into his his camera, and it's so
up in there.
perfect. And I'm just like laid back. I've got the boom mic here. It's not a big deal. It's awesome. I'm glad we could celebrate Limited today, because I think the conversation is always really interesting. Heard from the directly from the source, and your ability to expand on a lot of that is incredibly valuable for us to digest. But there are a couple things I really wanted to discuss with you, with the way that golf is trending right now. Not technically related to your product, but partly because one of the ones is with how much fitting has become a significant role in golf. There's this understanding that you can get down to the finite level of quality with the products that are fit to you. What does that look from your standpoint? How are you perceiving fitting now in 2024, especially as compared to, like, let's say 10 years ago?
Just from a consumer participation standpoint, it's way up, right? I mean, there might be double or triple the number of people getting fit. It needs to be everybody. It just does. Okay. Is a consumer going to walk out with something that is truly, truly custom built for them? Maybe not. It might still be a stock club, but it's going to be the right stock club, because it all matters. And I've heard so many consumers say, I'm not good enough, or it's not going to make a difference, or I'm working on my game. The working on my game thing, okay, I get it, but there's going to be a lot of like swing coaches say, yeah, people work on their game. They're not changing their delivery that much. It might make it more consistent, which is really cool, but changing the delivery, it'd be tough to do unless you're really working hard at it. So back to the I'm not good enough, that's crap, okay? It's not going to make a difference. Another pile of crap. It will make a difference. So consumers just go get fit. For the love of God, just go get fit. It makes a huge difference. I still walk down the tee line at ranges, and I'm playing with either strangers or buddies on the golf course. I'm like, wow, that driver is so poorly fit for you. You're spinning the crap out of it, okay? And it's flying way too high. Or conversely, you think you need a 9 degree, dude, you need a 12, okay? You are literally losing 40 yards on your driver because you're this macho stud that goes, I've always played a 9 degree stiff. It's like, no, you need a 13 degree freaking regular driver, okay? And you'll hit it 40 yards farther and straighter.
Well, nine today is like 6 20 years ago, wouldn't you say?
Yeah.
Like the way that things launched, it's so wildly different than it was.
Hell, take Ricky Fowler, for example. 5-6 years ago, I think he was playing an 8 or 9, right? And he didn't want to see much face. You know what he says now? I want to see the face. I want to see the face. Yes. Yeah. It's so valuable, and it's so accessible now for players to do it. They should just, for the love of gosh, go get fit. I can't say it enough. Yeah.
So I'll ask you a question more from a manufacturer's perspective, being that you do, to my understanding, spend a great deal of time making sure that the stock shafts that are promoted for each club fit a fairly large margin of golfers within that realm. If you would say to a regular golfer, if you want to go get fit for one club, let's say you don't want to go do the whole bag, what would you say would be? Would it be woods? Would it be putter? Would it be irons? Would it be wedges?
Wow.
And I'll make it easier and say not just that's the only one you get. Which one do you do first?
Okay. I broke into a sweat. Look, I'm going to back away from the camera now. I'm like, pick one? Are you kidding me?
My follow-up question is going to be worse, I promise.
Oh, perfect. That's perfect. I would start with the driver. And not just because it's a sexy, glory club. It's like, it's pretty important. Now, it's only 14 shots, right? When you say that, you got to hit a lot more with your irons, a lot more with wedges and putters. But getting that driver right can make a huge deal. It's just emotionally, intellectually, the value of hitting it a little longer, potentially a lot longer, depending upon what's in your bag currently, and straighter is pretty big. So I'd start there. The next one, I'm gonna go the other end of the spectrum.
Putter.
I don't think people don't pay enough attention to their putters. They just
Thank
don't.
you.
They just don't. Yeah.
When you're 40 putts around turns into 29, it's a big difference.
And I was listening to a couple guys the other day, and they're like, yeah, but it's just not sexy enough, right? It's like people don't care. It was actually I was listening to some podcast, and it was a putting instructor. He's like, yeah, I get it. Nobody thinks it's sexy. Nobody wants to practice putting. Nobody wants to get fit for a putter. Yeah, but you do when you do what you just described, 40 to 29 putts, or when you're in a match because you're rolling everything in, right? And your opponent, you can see their shoulders just slump because it's like we just talked about it earlier, Daniel. You hit 3 crappy shots on a par 5. I've got you down. Like, you're done. And you're rolling a 15, 20 footer. You're like, shit, he just beat me.
Yeah, what's better on the par 4? 2 or 3 stinkers and then a 30-foot putt for par, or beautiful drive down the middle onto the green and a 2-putt par? What's more upsetting to lose to?
Yeah, there's no doubt.
The chaos par is so much pain to lose to.
Yes.
Oh man.
Because like, look at the emotional swing. You went from I got this dude to I just lost. Yeah.
And especially if you're the guy with the 40 putts and your beautiful driver and iron game.
Yeah.
All right. So here's the more challenging follow-up. You ready for it?
Yes.
How underthought is the golf ball fit in golf right now?
Way under. Way. And I just experienced it. Okay. I'm not going to mention brands, but I will mention like constructions and characteristics. So I get fit. I hadn't been fit for over a year. And here I am. Of course, I try and get fit every year. Products come out, but we just got our fitting heads for these limited irons. So I was literally the first one. I knew they came in. I sent an email to Derek. Immediately go, Derek, when can you get me in? He goes, tomorrow. So I go in and I get fit for the irons, and I'm using a relatively low compression, soft covered tour type golf ball because I, number one, really want to be able to spin it around the greens, and 2, I just like the feel of a lower compression, soft covered golf ball. It's a tour ball, okay? And Derek's like, let's just try something just for giggles. He goes, your 7-iron spin's a little too low. It's like 4,500. I'm a picker, right? I get plenty of distance. I'm getting way more consistency with my limited irons. But he goes, let's just try a higher compression tour ball. And I'm an old school golf ball guy. I'm like, I know it's going to make a difference, but how big? How big? I'm like, how big? It was 500 RPM, almost 600 RPM. So I went from like 4,500 to 5,100. He goes, you have to play that ball. You have got to play a higher compression tour ball. And I said, but I don't like the feel around the greens. I don't like that click sound. And then I didn't even let him answer. I'm like, well, I know that the sum total of getting more spin on my irons and more control with my irons and better stopping power, I can eat the feel preference around the greens. Because I know I'll be able to spin that ball around the greens. I'll be able to stop it. I'll be able to stop it more. Yagley, give up on the little bitty feel issue you have, because it still feels good. So there's one example, real life example, happened within a week of right now. It's happened literally like last Thursday or Friday. I'm going to switch to a higher compression tour ball for my iron spin and iron control. And I will be a better golfer because of it. There's no doubt I'll be a better golfer.
So I had less of a, hey, when can you fit me in fitting experience with it, but I'll tell you my story and I think you'll enjoy it. So I've played the lower compression ball for a long time because I hit it into orbit every time and it lands like a pancake, so I don't really need to worry about spin. In fact, I could give it away. So I play the lower compression ball with the idea that I want to reduce it off the driver and nothing else is negatively impacted. And I gain quite a bit of distance from it. So I had switched away from that the last couple rounds to a more traditional compression number on a tour level ball. And what I found was I was actually spinning the ball back a ton off my irons and my wedges. And I was like landing them pin high. And they were very close to going in, so it was exciting. But my typical 2-footer, when I hit a shot like that, was now a 10 or 15-footer back to the hole because it spins away from it. So I was thinking, man, like, I can change my game to run it way past the hole and spin it back, which is exciting, or I can switch back to that other ball and continue to be successful, but also just pancake it by the hole instead of the spin. I just thought it was a really interesting practical example of the change in not a negative or technically positive way, but more shifting the style of play that exists. I thought that was fascinating, but I am of the impression that you find the ball you can work with, the ball you like to putt with, and specifically the one you can stop on greens is the most important things for me. So
Yeah, I would, and I agree with all that. It's funny, as a former golf ball guy, and then listening to what golf ball manufacturers now say, they're like, you should probably start around the green and move back, and I totally agree with that. But then I'm thinking, for me and for other golfers like yourself now too, it's like maybe you start around the green like categorically, and it might be. It sounds easy to say. It's like, are you going to play a tour ball, or are you going to play something that is a little more cost effective, and it has a little firmer cover, and you're okay with that around the green, right? So you're making that choice. Is it a tour ball or is it a distance sort of ball? And then, so now you've got the category, and then I would integrate all the stuff we just talked about. Like, okay, now what's it like on a wedge? What's it like on a 7-iron? What's it like off the driver? Because then you can get more discerning. Okay, am I going to play a high compression tour ball or a low compression tour ball? And then you've narrowed it in on the right golf ball for your entire game.
right.
And that was what was missing for me. And I was
So
playing fine, but I've got to switch.
Yeah. So final question on the golf ball. You play, let's
Yep.
say you go out and your buddy says, I'm just not that consistent. And then you watch him play. And for 18 holes, he plays 5 different versions of a golf ball. How quickly do you call him on it?
If he's my partner,
He's your friend.
really quick.
Yeah.
He's my friend. Really quick. Really quick. Because life's short, right? If I watch him, doing the ping pong match across the green, it was like, he actually could have spun that. Like, it's not like he bladed it. You caught it crisp, and that ball doesn't spin. Especially that moment. It's like, dude, do you really want a 20-foot downhill putt or a 30-foot downhill chip because you just blasted it over the green? No. No. They're like, what? It makes that much. Look, I'm going to get in close.
Yeah, there it is.
Difference? Yeah. Hey, butthead. Hello. It makes that much difference. It really does. Yeah.
Man,
So,
I always have such a good time talking with you. You are so good
Same.
on this show. We love it.
I love being on it. You kidding me? Thanks for giving me the opportunity to say all this stuff.
Of course. Do you have like final thoughts or questions for me or anything like that?
What type of iron is in your bag right now? You don't have to tell me the brand, model, anything. Like, no, just tell me the damn model. What are you
So
playing?
traditionally it's a player CB, yeah.
Okay. All right. Really, really excited for you to hit this iron. Like,
Yeah.
really excited.
It sounds cool. Can I tell you a little secret?
Yes. Tell me a big one.
So my wife and son, she's always played golf. She played JV in high school, so it was always part of her DNA.
Mm-hmm.
My son has taken it up. He's now 8, and he's killing it out there. He's loving life out there, and she's played more of it because of it. So last year, I got her into a set of, I don't think the brand new versions of Cobra irons, but the year back maybe, LTD maybe, or no, it matters, but it doesn't matter for this example.
Got it.
She freaking loves your iron, your product. Hammers the driver, loves the irons. It is so fun watching her get excited to hit a golf ball. She's out there, she's doing it, she loves it, and I want to thank you guys for connecting our family a little bit more for that.
That moment. Now I got it secondhand from you. It's not hearsay because we trust your relating of that moment, right? You could take that to court. People ask me, like, isn't it really cool working with like tour players? I'm like, yeah, it is. Okay. We give them golf clubs. They get them for free from us, right? We actually pay them to play the damn golf clubs. What you just described by far is my favorite moment. And I could be on a golf course, at a driving range, on an airplane, right? I'm wearing some Cobra headgear. Like, they're like, hey, what's the deal? Like, I'm like, I work there. And when they light up and they go, yeah, I bought that LTD driver or that Aerojet driver or that dark speed driver or irons or putter, whatever. And they lean in like I am. They go, oh man, It's so good. I love it. Right?
Well, it's funny, man, because
that's my favorite moment.
So she's watched me write for THP. She's watched me do video reviews for THP. It's been I think I've been on the site for almost 14 years this year, or maybe 15, and it's just been an adventure for her to follow it. But she never really got it. She had a set of older clubs that were 10 or something years old. So I'm like, screw it. I'm just gonna buy them for her, and we'll see what happens. She's clearly invested in it. Our son's playing a lot. So I go and I buy these things, and the first thing she does when she gets out there and just starts pounding it, and she's like, "Oh my god!"
There you go.
So yeah, I mean that's such a great moment for our family, and it was fun to have Cobra be a part of it. And I do want to have a little call to action here for you guys. I've been bugging her to come on the show, and she hasn't yet. So if you want to listen to her come on and talk Cobra product, let me know.
Absolutely. I mean, you'll see that comment. Yeah.
There you go. So anyways, Yags, you're the man. I love it. Thank you so much.
Daniel, always fun, enlightening, challenging. You're a good dude. This is a great show. I never miss it. Yeah.
Thank you so
Keep
much.
Up the good work.
Hey guys, if you're playing golf this weekend, have fun. Make it count. Play the same golf ball all the way through and see what you think. You'll get fit. Yeah. Check out the new limited irons from Cobra and get excited about what's to come from them, because clearly they're not messing around. There's some really cool innovation going on with this face here on the right. We'll see you guys next week.
Take care, everyone. Play a lot of golf.